So I have good news and bad news, and it's the same news. And it's we're going to talk about V6. Hopefully it will be good for you. I'm going to try to concentrate on all the problems we had, so you can make fun of us when you see us in the hallways. Just to give you some idea of the scope of the Abilene backbone and whether or not this is applicable to you. We're GSR-based and are now T640-based with a 7200 tunnel router. We have about 102 BGP sessions, external BGP sessions, and about 37 of those are supporting IPv6. The customers are actually running IPv6, or peering network is running IPv6. Unlike our IPv4 service, the IPv6 service has no AUP, so we can accept commercial entities or commercial peers, and that's actually provided some interesting problems for us. One of the things we've tried to do is to have our IPv4 and IPv6 filters exactly the same. So we use the same filter whether you're using v4 or v6. That'll come into play here a little later when I start discussing the fun. So Abilene in the past has only had a /22 for IPv4 service, and that /22 was just used to number the backbone with. When we brought up v6, a new problem arose, and that was assigning address space. We've never done this before. There's some administrative overhead and there's some technical overhead related to aggregation. We spent a lot of time coming up with an addressing plan to handle 2 to the 128th power worth of addresses. And we thought we did a good job. And then a year went by and we found out that we had not done a good job. We had not planned enough for growth. We had run out of address space on our /35, and the transition to the /32 was not as good as it could have been. We'll go into that a little bit. We also have some delegation duties in DNS that we have not previously had. We are assigning folks /40s and /48s for their networks, and so there are some DNS delegation duties there. And again, that's not something that we've had to worry about in the past, and that's not something we had expertise in, at least at the backbone level. Just to give you a brief overview of our eBGP settings, we're trying to use the exact same routing policy for both your v4 and v6 session. We accept a specific /40 or /48 from a peer or from a customer. We expect to receive just one route from our customers, which means v6 is working the way it should. One of the interesting ideas here is, since most of our customers only have a single vendor providing them IPv6, us, technically we don't need to run BGP with them. We could just use static routes, but we use BGP in order to gain a little bit more experience with v6 BGP. We accept any prefix from our peering networks, and that causes problems, as you'll see later, with longest match. Most of our problems are longest match related. We aggregate internally and only pass /16s through /32s to our peers and customers. That's going to cause problems also, and I have a slide on that. It's very interesting. Our policy for the tunnels are a little different. In fact, the tunnel router has been quite a bit of a problem for us, and we'll go into a little more detail on that. Finally, when I say that we accept any peer from peer networks, that's any prefix from a peer network, that's not technically correct. We do, of course, apply a sanity filter. One of the interesting aspects of adding v6 to your network is your IGP. We were running OSPF as our IGP, and of course discovered that that would not do for v6, since we needed an IGP that supported it. That meant ISIS, and that meant deploying ISIS at the same time we were running OSPF. At that time, there was a problem. You could not simply run ISIS for v6. You had to run ISIS for both v6 and v4, and twiddle with your distances and preferences in order to make OSPF the preferred protocol for OSPF, or OSPF the preferred protocol for v4, and ISIS the preferred protocol for v6. I think in the ensuing year or so that we've been doing this, I don't believe that's a limitation anymore. I believe you can run ISIS with just v6 support if you should so choose. We actually encountered the only routing loop I have ever seen in my life during the IGP transition. I have a very interesting slide on that, and I'm happy to point out that I caused it. After we deployed both OSPF and ISIS, we fiddled with the metrics after about 6 months and made ISIS the preferred protocol for v4, and then finally removed OSPF. Those 2 steps were actually very painless. They worked without any problems at all. Most of our problems were involved with both running OSPF and ISIS, with one protocol preferred for IPv4 and a different protocol preferred for IPv6. So these are the fun slides. These are all the bad things that happened. And I think you'll see that most of these apply to both IPv4 and IPv6. And if you're really old, you can remember seeing some of these in your IPv4 networks. The first problem we had was ghost routes. This is a route where a situation in which let's say you announce both a 32 and a 35, and then at some point you withdraw the /35 announcement. What if someone doesn't honor that withdrawal? What if they keep propagating that? At that point, you're advertising a /32, and one of your peers is advertising your /35, or re-advertising your /35. Due to longest maps, this means the traffic's going to flow through the /35. Now, you can see how this would apply to both v4 and v6. You can imagine advertising a /20 and a /24, withdrawing the /24, and then someone not honoring that and continuing to advertise it. What makes this a problem in v6, or what makes this show up more in v6, is the abundance of tunnel routers and the people that are running routing on their PCs. So somewhere you have a Linux box running an IPv6 routing protocol. The developer has a bug in the code. The guy never updates the code. And these are peering with us, either over our tunnel router or they're peering with one of our peers. This has actually causes quite a few problems. We've had at least 3 instances of this where they caused major problems for IPv6 TCP flows. In one case, we attempted to withdraw our /35 before a major conference, about a week before, and one of our peer networks lost the withdrawal message and continued to propagate that /35. In 2 other cases, we were re-advertising a prefix that someone else was advertising to us, and we should not have been, and were, causing them problems. This is my Bubba Net slide showing an example of this. We advertised both a /32 and a /35 to Bubba Net and to CANet. At some point we withdraw the /35. Bubba Net doesn't recognize that, and through their own peering with CANet, continues to advertise our /35. And at that point, traffic between CANet and Abilene is diverted through probably a very slow tunnel through Bubba Net. A related problem is misconfigured BGP filters. This is a longest match problem again, but rather than broken router code, you have broken routing engineers. Through some faults of their own, they have included a prefix list which is not filtering the way they should, and so you receive a more specific route, a /40 or a /64, through a tunnel, for example, or they're re-advertising someone else's prefixes. In both of these cases, these things can happen in the IPv4 world, but they don't tend to be as big of a problem. If someone misconfigures a prefix list and a /24 gets advertised where it shouldn't, it's not too much of a problem, right? You've got maybe 256 machines or so that are affected. But if you misconfigure and advertise a /35 when you shouldn't be, suddenly you've taken down every research institution in North America. So these can show up in v4, but they don't cause as many problems. Here we have yet another slide showing this. We advertise, or CANet advertises some prefixes to Bubba, and Bubba re-advertises a /40 when they shouldn't be. Because they re-advertise that /40 over a very slow connection, our traffic to CANet is diverted over that slow connection instead of over the much faster direct connection. This can be a problem, and we see this problem mostly in tunnels. The tunnel connections are, of course, significantly slower than our native connections, and if it's misconfigured in a native connection, it's not really a problem, since most of our connections at this point are OC12 or higher. But when we receive these prefixes over the tunnels, things slow down dramatically. So this was my routing loop. That's how I like to call this slide. You'll notice this slide lists the distance and preference values for both OSPF and ISIS for both internal and external routes for Cisco's and Junipers. And one thing in particular I'd like to point out is the level 2 preference on the Junipers. It's 18, the level 2 internal preference. And if you look at the ISIS and if you look at the ISIS preference on the Juniper, or the OSPF preference on the Juniper, on the external routes, you can see that it's 150. So you've got a case where an ISIS preference is less than an OSPF preference. We knew that this was a problem, and we fiddled with our distances and preferences in our routing protocols to set the OSPF external preference, which was 150, to 11, to make it lower than that ISIS preference. On every router we had, that someone forgot to do New York City. We were redistributing our connected routes into OSPF, and we weren't using next hop self. So our route to our peers was an IGP learned route. We had a case where the New York router thought that the best route to one of our customers was through Chicago, and it was getting that through ISIS because the ISIS preference was 18, and the OSPF preference was misconfigured to 150. The Chicago router was actually operating correctly, and it had the best hop as being New York. We got a call in the middle of the night, and again, this was a high bandwidth TCP flow, and this is one of the few cases where our V6 experiments actually affected our V4 traffic, and this was quite serious. We had another case where V6 experimentation caused V4 problems, and that was with an equal cost path. This was right when we had first switched over from OSPF to ISIS. So this is our stage 2, and we were just using ISIS. Through some fault of our own, we had misconfigured the metrics on the backbones, and were only setting level 2 metrics. We had not turned off level 1. So even though we had our metrics set correctly, and in this particular case, the path should have been LA, Chicago, New York, we had an equal cost path. That's because I don't show the level 1 metric, which was 0, because it wasn't set. So the path from LA to New York was actually equal cost. There's really no one to blame here except ourselves. The lesson to learn from this is to explicitly set your metrics and explicitly turn the protocols on and off, and don't rely on the default values. And in fact, we learned that in quite a few different cases. So this is one of my favorite problems, IPv6 typos. There's lots of F's and lots of colons in IPv6 addresses, and you can quite easily make a mistake. That last route on the slide should have a double F right after the 2001-468, indicating that it's a backbone circuit. It does not. And this actually doesn't cause any problems at all in our network. I have a few slides later on that shows why. The way we find these IPv6 typos is, strangely enough, through our DNS. When we compare our connected routes to our DNS entries for DNS lookup, we inevitably find some that don't match, and we find that someone has left off a digit somewhere or inserted a digit somewhere where they should not have. I think this mostly has to do with the inexperience with V6. As people begin to work more with them, as our engineers begin to work more with V6, this shouldn't be as big an issue. This was one of my favorite problems. And again, this is one of the problems where V6 actually affected our V4 traffic. We'd done a code upgrade in the middle of the night one night to fix some multicast bugs, and the next morning we found that our IPv4 BGP next hops were very strange. 32.14104. Well, if you convert that V4 address into a V6 address, it's actually 2001-468. What we had happening was that our V6 BGP sessions were passing V4 routes across them, and the next hop was being translated from a V6 address to the first 32 bits of it was being translated into a v4 address. This one was fun. It's also really obvious and really easy to fix. Again, sloppy configs caused this. We had not been turning protocols on and off explicitly in our BGP configs. We had just been setting them to whatever they were, and we'd gotten away with it until we'd done a code upgrade and the code had changed some. And again, the lesson to learn here is to explicitly set what you're going to pass and what you're not going to pass. So this is the next top slide I was referring to a few slides earlier when I said that the IPv6 typos didn't matter. Of course, if you had a point-to-point connection and you had a v4 address on one end and the v4 address on the other end wasn't on the same network, subnet, you would have problems. But that's not the case in v6, because v6 uses link local addresses in the end to resolve the point-to-point connectivity. So even though your v6 subnets may be different on the two interfaces, that's not actually a problem. The router's actually smarter than you are. It knows what the link local address is of that interface, and it knows what the link local address is of the other interface due to the protocols it's running, and it figures things out. We actually had a case where our LA to Houston link had a typo, and the two interfaces were not on the same subnet, and no one knew about it. Traffic routed perfectly. It wasn't until we were checking our DNS records just to make sure we had everything in the DNS that we discovered the problem. It's not even really a problem. So this is kind of a basic v6 BGP issue, and that's that your v6 router has to have a v4 address somewhere on it. The BGP protocol is going to require that you have a 32-bit router ID, and 32 bits, that's a v4 address, right? Most of the routing vendors will use a v4 address on the box to do that. You have to either have a v4 address or set your router ID explicitly to a v4 address. You need one or the other to have this function. So we have a few ongoing issues that we haven't been able to figure out yet, and some of these are very difficult indeed. We're having serious problems with the lack of v6 support in the MIBs. We do most of our monitoring proactively, so we poll the routers every 20 seconds for the status of the BGP and ISIS sessions. And we encode the BGP v4 address into the SNMP OID to get that status. Well, you can't do that in v6. And in fact, there are a lot of issues like that in v6. In the v4 world, the routing vendors, quite a few of them, have gone out and created some proprietary MIBs. That hasn't been the case so far in v6, and that's actually hampering us quite a bit. And that's hampering our operational issues. We actually don't have a way to monitor our v6 customers. If someone goes down, and in fact someone did go down off of our Chicago router for 2 days before anyone knew there was a problem, we have no way to tell. One of the more serious problems is packet filtering, and that's the problem that keeps me up at night. For most routers, you can only look into the very first v6 header to do filtering on. And with the various types of DDoS, you typically want to look into the TCP or UDP header. Well, that's not necessarily the first header anymore, right? You could have an encapsulating security protocol, you could have a router option, you could have something in there. And because of that, you can no longer filter on TCP or UDP port numbers. It's actually quite possible now to generate half a dozen different DDoS attacks that can't be stopped other than shutting down the interface or BGP session. There's no other way to stop it. This is the one that actually keeps me up at night. No one's actually done it yet that I know of, but it's pretty much a serious issue. A related issue is to just how much traffic there is. We have no idea how much traffic there is on our network in terms of v6 traffic. In the old days, you just had a v4 address on the interface, and you knew how much traffic there was on the interface for v4. It was the only protocol. Now you've added a second protocol. How much of that traffic is v4 and how much is v6? We just don't know. I'm going to skip the next minute and talk about our engineering group. Some of the engineers are actually very scared of v6. They're very intimidated by all the Fs and all the colons and all the zeros. They're even as scared of v6 as they are of multicast. And that really shouldn't be the case. But for some reason, all those colons and zeros just really dig into them, and they don't even want to think about v6. Lastly, there's the addressing plan. We had a very bright mathematician had designed our addressing plan, and we thought we had enough room for growth in it, and we didn't. We've renumbered the network 3 times so far to try to add additional growth, and we're probably going to do it a 4th time. The good news is those renumberings went without a plan. They took about an hour, and there was absolutely no downtime involved at all. The bad news is we're going to have to renumber again. My advice would be to have a very good addressing plan that allows for growth. So the other really big issue is which prefixes we're going to pass our peers. In the v4 world, you might use meds to influence an exit point on your network. Well, that was great because you had lots of v4 routes. With v6, you have 1 route. Abilene has 1/32. CANet has 1/32. How do I know which is the best exit point from my network to get to CANet? Is it the Vancouver, Winnipeg, or Toronto exit point? I don't know.
I just wanted to have a clarification.
Yeah.
Oh, I'm Dave Meyer. Sorry.
Hi, Dave.
Hi. I was just wondering, did you say you're about on your 4th addressing plan and that one of them or some number of them were designed by mathematicians? Did you say that?
Yes, I did, and there may be some causality relation there.
Get the next one done by a lawyer.
I'm just I'm just kind of curious. You know, we've been around the addressing plan thing a while on the v4 space. Have we not learned anything, or is it just a qualitatively different, harder? Are we in a completely different space, or what's happening there? Because one would imagine that if you had IPv4 and you designed a successor, that one of the things you would handle is addressing.
That's right. You know, I think the vast amount of addresses combined with the kind of super aggregation is our problem here. I'm not sure that we have learned anything from it. Abilene.
Randy Bush, IIJ. I happen to be part of a dual stack v6, v4 network over in Japan. I want to say that my engineering people are right now taking these foils and sending them to the marketing people who've been complaining why we won't BGP peer over tunnels. And thank you for demonstrating why not to do it.
There's a very good reason.
Right. Do you use static or autoconf for services and router interfaces?
Do we use?
Static addressing or autoconf?
We use static addresses on the router interfaces.
And for services?
And for services.
Yeah. And by the way, a router ID does not have to be an IP address. It's just any 32 bits.
It's just something, right? Right. So I have a little more information here, and that's the. Oh, I'm sorry. I'm off.
1 minute. Well, take a minute, but go for it.
We have all of our configs without passwords online, and the router proxy. So you can actually look at how we're doing things if you'd like to. Probably the best way to do that is through the Abilene router proxy, the 3rd URL on the list. Okay?
Thanks, Robert.
I was trying to, Randy. When you talk about the ghost routes,
yep.
Is the AS path normal on those? Because what we saw with somebody else's work I presented was that there's these routes that never seem to go away when they're withdrawn, and the AS path becomes this big, long, ugly,
yep.
huge thing. Is that the same problem?
It's very similar. In 2 of the cases, we've actually seen very long AS paths. And had we been filtering on the number of AS hops in the AS path, that probably would have fixed the problem. In one case, that had not happened. So we had a very short AS path.
It's got to, okay. Have you seen, well, anyway, maybe we should talk offline, because maybe you haven't seen, maybe you could talk to the other guy and somebody could actually figure out what the bug is that's causing that.
Okay.
Thanks, Grover.